Hello everybody, good afternoon. Welcome to our second presentation for SMARTEDGE series, and I'm very excited to have our new speaker here, Nour Shawky, coming all the way from Egypt to Canada and in his way to New York. So I appreciate the fact that you stopped here to give us some talk and to class. Nour is the CEO of at Softec International in the United Arab Emirates. And I'll let him talk about what his talk. I'm not going to basically summarize the bio, but today he's giving us a talk about smart cities and public safety solutions. He has been engaged in so many projects, different national scales and regional scales. He started Softec International, and maybe one of the leading smart city and Internet of Things companies. As you can see, we're getting several global awards from Microsoft and other, and Israel. Did you post something of Israel? And he got his bachelor's from Germany with a degree in computer science, and he got his master's degree from University College London in software engineering. And I'll just stop at here and look over to the center.
Hello everyone, thank you Tarek for the introduction. Thank you all for having me. I'm very glad and proud to be here. My first time in Indiana, so it's also a nice experience to learn about new place. I'm going to talk about intelligent solutions. I'm going to have a few examples, some very specific case studies, and I'll tap into a few initiatives how technology can enable public safety organizations to improve the performance and address national challenges. And first of all, we are part of the Microsoft CityNext initiative. CityNext is it's a global portfolio of solutions for smart city. These solutions, they come either from Microsoft itself or from a number of companies all over the world, which are Microsoft partners and use Microsoft technologies. It's a very interesting set of solutions that cities can look at, and different solutions they can combine to make their cities smarter. So there's a lot of best practices and case studies and solutions that have been implemented with know-how in specific cities before. A quick overview, the CityNext initiative is splitting all solutions into those 5 areas. One is digital cities, safer cities, healthy cities, educated cities, and sustainable cities. So an initiative like, for example, the smart farming or agro would be under sustainable cities. Today I'm going to mainly focus under the safer city side. I will focus on making cities safer and improving the performance of public safety organizations. Let me start with a video. This video is actually an implementation done in Abu Dhabi for a combination of projects.
نوع المركبة مقدارا أزرق اللون. استلمت. صحيح، البيانات موجودة على نظام الدورية الذكية. صحيح، تم ضبط المركبة المذكورة عن طريق الدورية الذكية بالاتجاه المعاكس بسرعة 201.
really important because it's
قال لا يا جناح ثلاثة يعطيك العافية سيتم متابعة المركبة عبر الرادارات الذكية المنتشرة في المدينة.
So deactivate the radars.
إلى عموم الدوريات تشاهد المركبة المطلوبة على رادار IP 33 غرب. آدم 34 حاليا قريب من الموقع. آدم 34 تم رصد المركبة عبر رادار IP 39 جنوب بسرعة منخفضة. توجه إلى المركبة المطلوبة. حاليا تم مشاهدة المركبة المطلوبة عبر رادار IP 47 غرب. آدم 34 قبل الوقت المستغرق للوصول إلى الموقع. صحيح لحظات. للعلم تم اختراق المركبة المطلوبة بعد رادار IP 49. للأهمية على جميع الدوريات البحث والتحري عن المركبة المطلوبة في القطاع. صحيح حاليا في الموقع جاري عملية المسح عن المركبة المطلوبة في القطاع.
Now they lost him, they're going to swipe the area and activate the cameras with the plate recognition, which is mounted on top of the vehicle.
عمليات تم العثور على المركبة المطلوبة في حالة وقوف نهائي. موقف رقم 5 والسائق غير موجود. للعلم جميع الدوريات تم العثور على المركبة المطلوبة. احتمال وجود الشخص راجلا في محيط 200 متر. تم تفعيل أنظمة بصمة الوجه على جميع الدوريات. يتم حاليا فرض طرق أمنية للقطاع وتوجيه دوريات إضافية باتجاهكم. تم تحويل الحركة بعيدا عن القطاع لتأمين مستخدمي الطريق. يرجى أخذ الحيطة والحذر. عمليات تم العثور على المشتبه عن طريق بصمة الوجه. صحيح التطابق سليم. يمكن استيقاظ المذكور والقبض عليه فورا. المشتبه الآن في الفراغ. حاليا يتم ملاحقة المذكور. أرسل دوريات المساندة فورا. صحيح تابع المطاردة. تمت عملية الإخلاء وبيشن إشارات الخلاص. لتحديد المسار وإغلاق جميع المداخل والمخارج لإبعاد خارج المدينة.
And the roadblock set up.
المذكور رافض الوقوف وما زلنا نطارده وسرعته في تزايد. صحيح تم تحريك دوريات المساندة والGTR بالاتجاه إليكم. للعلم يتم إغلاق الجسر عن طريق الدعم الأمني وتغطية المطاردة عبر الجناح الجوي. عمليات سرعة المركبة عالية والمسافة تتباعد. الدعم الأمني معاكم على الشبكة. الGTR وجناح الجو على وشك الوصول. الجسر مغرق وعلى تم الاستعداد لإيقاف المركبة. صحيح نرى المركبة باتجاهها. تم إيقاف المركبة والقبض على المذكور. يعطيكم العافية جميع الوحدات.
Okay, so this was shot by a Hollywood director, so you can fairly say it's slightly exaggerated. But these are all combinations of systems that Abu Dhabi implemented over the past years. So these are actually things that are happening on the ground. So it's not really very far away from reality. And I'll explain a little bit on this journey. First of all, the motivation for my talk today is to start with the real challenges that almost all the public safety organizations face worldwide. First of all, the increase of urbanization, which increases the crime rate, make cities bigger and more dense. The real threat of terrorism, which we are facing now almost on a daily basis. The increased demands of citizens to be safer, and the increased demands towards the government to provide this level of safety. And then obviously coupled with increased limitations in resources, so resources are no longer enough to cope with these increased challenges, and then obviously in many cases also limitations of budgets. So the question is whether there is a possibility with technology, by making cities smarter, to achieve more, to increase public safety with less amount of resources, or with the current amount of resources, but still able to cope with the increased challenges. And I will mainly focus, and the time is not enough to talk about all the aspects of public safety, but I will focus today about improving first response to emergencies and to crisis. And I will split it into four main areas. One is the detection infrastructure, the domain awareness, threat detection, and intelligence-led first response. So detection infrastructure, we basically talk about the underlying infrastructure, which gives us real-time access to information. Domain awareness, we're talking about processing this information in order for us to be aware of what's happening on the ground. Threat detection makes things a little bit more intelligent, and threat detection is more about automating information and using a combination, a correlation of the information that comes from the underlying infrastructure that will eventually lead to intelligent detection of possible threats, and therefore also proactive policing, if you like. And all of this would contribute to making first response more intelligent, increase saving lives, reduce the possibility of accidents or incidents, possible prevention of crime or terror attacks. So starting with the detection infrastructure, here I'm really talking about sources of information. So what would lead us to respond to an incident? So traditionally we're talking about call taking, right? So I would just make a 911 call, and that would be the call for service, and based on that we would dispatch our task force to send them to the location of the incident. But there are other ways of detecting incidents as well. One of them are cameras with the intelligent software around them to analyze what's happening and to automate basically the video feeds in a way that would enable the solution to detect specific possible threats or possible causes to dispatch first responders. Sensors and devices. So we looked at the video. So almost all the information that was fed into the command and control room came from sensors and devices, so from machines basically on the ground, and not from manual information coming from people. So starting from the actual detection of the incident, which is the dangerous violation, which I'm going to talk a little bit about later today. Starting from detection of the incident, we actually start chasing the guy, up to finding out where the guy is exactly, and narrowing him down, and then having access to the tracking systems in order to make it easier to catch him without putting the lives of others in danger. So all of this, I'm going to give you a number of examples on other sensors and devices as well. Social networks are increasingly important. We heard the sad story yesterday in Nice, and we found how quickly information is being fed into the social networks. So it's almost like you get more information from Facebook and Twitter than from the actual news channels. So social networks are a huge source of real-time information, because people on the ground, using their mobile phones, they can give you immediate access to this information, location-based information, pictures, videos, which gives you increased situational awareness of what's happening on the ground. So this is increasingly something we should rely on as a source of information in response to the incidents. And mobile apps, which I mean, a big part of making cities smarter is mobility, mobile solutions. So in this case, we will talk about apps that cities will develop and publish to citizens in order to better cooperate and align with public safety organizations. Now, examples for sensors that could be used as sources of information as a call for service, automated call for service. So we talked about the traffic sensors, and we saw a few examples in the video. Fire sensors, there was a very famous case in Dubai over New Year's Eve the last year, and there was this big building which is right in front of the largest tower in the world, the Burj Khalifa, and it had a huge fire. And luckily there were no incidents, no injuries at all. And the main reason is that the civil defense was there before anybody made a phone call. And that is mainly because the fire sensors were connected to the mobile network, and as soon as the fire started, the civil defense and the National Command and Control Center was immediately informed, and they immediately started dispatching the first responders before anyone even found out that there was a fire and made a phone call. Other examples are alarm systems, gunshot sensors, which are heavily deployed in New York, for example. After 9/11, they started putting different gunshot sensors in different high security areas. Weather and earthquake sensors, so incidents are not necessarily man-made. There might be other types of incidents that we have to respond to. Radioactivity sensors. Connected cars, increasingly e-calls become more significant, which are basically devices installed inside vehicles that would automatically send crash reports if a vehicle crashes, or if there's an accident, or if it turns over or has some sort of harsh break. And smart officer sensors are becoming increasingly popular as well, which are basically wearables with embedded health checks. And if the stress level of an officer would go up, for example, this is an alert that you put to the command and control room, because this might be a situation in which he's in danger and needs backup. So if you look at all of this, these are all sources of information. So if any of these sensors triggers an alert, we would actually start dispatching people without anybody calling us. So there's no 911 phone call involved in this kind of activities. Social network monitoring, extremely important, and it provides two things. One is, in some cases, if you monitor the network, if you look for specific analysis of the network. For example, if a terror organization starts posting information about possible terror threats. For example, if a suspect posts a picture of himself in front of a gas station or in front of a train station. These are all possible areas where you have to be careful and watch out for this guy. If you analyze what all the different terror organizations or organizations that are affiliated to terror organizations, what they are tweeting, what they are saying, if this is properly analyzed in an automated way, you might be able to detect possible incidents in advance and start monitoring these people more detailed. That would be pre the incident. Post the incident, it's very important to track and trace all the tweets and the feeds that come from the area, because it gives you a lot of real-time access to information which you otherwise wouldn't be able to have. You cannot put the camera everywhere, but there are people around the incident who could post pictures or videos, and that will give you more information on what is happening on the ground during the situation. And apps become increasingly popular. This is a screenshot of one of the apps in UAE with the National Ambulance. And here, actually, this would enable you to interact with public safety organizations in a more effective way. It would solve, for example, one of the challenges many organizations have, which is to really immediately find out where the person is located. With the apps, you have the advantage that you would send your GPS location coordinates, you immediately dispatch the officer, send the coordinates to his vehicle, and that will significantly reduce the response time. So, again, as a summary, detection infrastructure for us is a huge opportunity to significantly reduce response times, to proactively engage our customers, and to improve our response to incidents and accidents. The next level is domain awareness. So now that we have access to this kind of information, we will be able to be better aware of what's going on the ground. And here I want to show you another video, this time from New York Police, NYPD.
What if the cameras could all be watched in real time at a central location? Amazingly, today there is only one city where this is known to be possible: New York. When it comes to technology, Police Commissioner Ray Kelly is a true believer and an early adopter.
We're big fans of cameras here, which has been a tremendous force multiplier, if you will, for law enforcement.
The city's ambitious effort to connect and monitor thousands of surveillance cameras has never been tried before. The result is called the Domain Awareness System.
This is the state of the art. It is the most sophisticated camera system that you'll see across the world.
Domain awareness takes in a steady stream of data from license plate readers, environmental sensors, and 4,000 closed-circuit cameras, the vast majority privately owned. The city designed the system after carefully studying the extensive CCTV network in London and trying to improve on it.
The reason that this is state-of-the-art is because this shows officers in real time what's happening, rather than being useful mainly for post-incident investigations, as is the system in London.
911, where's your emergency?
The system is integrated with 911 calls, so possible terrorist activity is flagged, and detailed information about the address is displayed, as well as the location of nearby cameras, which can be called up live or rewound as far back as 30 days. It reads license plates in every lane of every bridge and tunnel coming into Lower Manhattan and compares them to terror watch lists. It is also programmed to automatically spot suspicious behavior, like unattended bags sitting on a sidewalk. And it can search through huge amounts of video data to find specific shapes, movements, or colors. Watch what happens when you ask it to look for people wearing red near the New York Stock Exchange.
It's really a matter of 1 or 2 seconds. If these cameras weren't all on one system, what you'd have to do is you'd have to go to a pole, retrieve the video data, and then each camera would have to be looked at individually by a person to pull out the red shirt.
So traditionally, all these cameras and sensors are used for post-investigations, right? So you go back and see what has happened and who was the guy. But in here, what was so different is the real-time processing as the information comes in, including, for example, automatic analysis of suspicious behavior. If, for example, a bag is left in the airport or on the street and it's unattended, so that could be automated procedure. You don't have to wait for somebody to look at the bag and suspect that there's something wrong and then make a phone call. You could actually immediately detect these kind of things using advanced video analytics. Similar, more advanced kind of analytics would be human behavior. So if somebody is acting strange or is spending too much time standing inside the high security zone, for example. So these kind of things are, so we could get early possible threat detection. And the most interesting thing I found is actually the real-time analysis in terms of sweeping all the cameras around to find specific people that you're currently looking for. So they were looking for a red shirt, and then the system would go throughout all the feeds and find somebody wearing a red shirt within the New York Stock Exchange area. So that's a huge opportunity to improve the way you hunt down suspects or possible criminals, or if the incident already happened, then at least hunt them down and get them arrested. Now, by integrating all of this, I mean, imagine the amount of resources you would need to have if you don't have these kind of systems in place. You would never be able first to achieve this level of sophistication, and it would be extremely expensive, and you would not be able to cope with the increased threat levels and the increased organization and the socioeconomic changes and all of that. But with technology, it's possible to keep or even reduce the amount of capacity you have and leave a lot to the technological components to do a lot of work for us and enable us to react more fast and more proactively. Now, we talked already a little bit about this. I just want to highlight it give a few examples about that, which is the threat analysis. And this is, I think, the most interesting part because it enables you to do proactive policing. So it enables you to actually, instead of reacting after the incident took place, you start looking into possible areas of threats and proactively engage. Here is one example. This is the one we saw in the video in the beginning. It's a similar example. It's related to tracking dangerous violators. So there's a difference between a law-abiding citizen who is overspeeding and who gets fined. We all get fined. And somebody who needs to get off the road because he's a danger to others. Now you can define on what this danger means and what is the level, where do you draw the line between a traffic fine and actually a dangerous set of violations. That could be, for example, 2 or 3 red light violations within a time span of 10 minutes. Or it could be just speeding over 200 miles an hour. And there could be different types of settings that you could identify yourself, and each city could set its own level of safety standards and decide when somebody has reached a level where he's almost close to criminal behavior, needs to get off the road because he is a danger to others. Now, this kind of detection, you would have all these different features. You have the cameras, the red lights, the speed cameras, the traffic counters, the radars. All of this, if the city is smart enough and properly connected, and you can get these feeds in real time, then you can actually correlate the information coming from different systems into a single source of truth, and based on that, detect these kind of guys and then track them and hunt them down like we saw in the video. Another example, and this is, you can't say this has been fully implemented yet, but a lot of these components are already working on the ground in a certain way in some of the countries. Here's an example of because in many cases, terror attacks come from people that come from abroad. They're not necessarily from people inside the city or inside the country. So very often you could identify patterns where you say somebody comes into the country, stays for a few days, rents a car, takes it near a high security zone, visits the zone a few times, and then attacks. So if you have these kind of patterns and you can analyze these kind of patterns, then you can start asking your system to immediately detect these kind of people once they notice such a behavior in an automated way. So what that would mean is actually to integrate all the different systems inside the city that are out there to get them all connected. So for example, going through the customs, that would be triggered in the system. Renting the car, based on that you can do plate number recognition. That would basically similar technology to what we saw in the video in the beginning. By integrating all the hotels, you will know where this guy checked in. And if the vehicle is detected inside a high security zone, you would actually be able to dispatch. That's a possible threat, not necessarily criminal behavior, but it's a possible threat. So you would actually just dispatch the nearest patrol, ask them to look out for this guy, maybe stop and question, find out more about what he's doing, or just following him. There is, I know for a fact that in Saudi Arabia, a big part of this has been implemented. So there is a national platform, for example, that integrates all the hotels and all the car rental companies with the airport. So this part, I know for a fact it has already been implemented. And then there's a part similar to the one that's in Abu Dhabi, which is the ANPR, so detecting fake numbers, which is around here. So actually, I can imagine the next step will be to integrate both together, and then you'll be able to actually do this kind of scenarios. And not everything is man-made. There is also a possible threat coming from earthquakes or bad weather. Even just visibility going down on the high road is already a possible threat, could lead to major accidents. So here actually in Abu Dhabi there are smart towers on the road that have weather sensors. They will automatically trigger in a specific area. You have a fog alert or a sandstorm, and visibility goes down. And you would actually immediately automate your standard operating procedures. Meaning, number one, you would push changes of the speed limits to the digital signages on the road. So it actually asks people to slow down and change the speed limit, and accordingly also change the level of where you get fined. Number two would be to dispatch nearby ambulances and patrol officers. Just make sure they're close, so in case an accident happens, the response time gets reduced. And then inform the public through links to the TV stations, to radio channels, to social networks, Facebook, Twitter, through city apps. So you would immediately also inform the public to stay out of this road, or that the visibility is going down, try to take the road a little bit later, try to avoid it if you can, and so forth. So here, it's a very fast and efficient and proactive, using simple sensor technology and using standard operating procedures that you would actually configure inside your systems to be able to try to at least prevent or reduce the probability of accidents taking place due to bad weather. So, if you combine all of this with first response, then your first response becomes more intelligent. You have significantly reduced response times, you are much more proactive, it's much likely that you're going to save lives, that you prevent incidents from happening. On top of all of that, you can build very intelligent command and control centers, so the city can actually have a central operation that is smart enough to manage its resources in a very efficient way. You can integrate your emergency management procedures, coordinate your agencies. You can link all the agencies together, so you have ambulances, civil defense, also fire brigades basically, and police working together, better coordinated. And the last point I want to mention about this is the mobility part of things. So if you equip vehicles with the right mobility solution, you will also be able to push information much more efficiently to the task force on the ground. For example, immediate information about the traffic-related incidents, all the domain awareness we talked about, you can selectively send that to the officer so that he also has a picture of what is happening. And things like real-time navigation based on traffic conditions, if there are traffic jams or roadworks in specific areas. The mobility solutions that we can help to significantly improve the response and empower also the officers to, instead of always using the radio to make use of the application which is immediately, which is directly hooked up with the command and control center. Now, there are additional functions inside here which will enable the officer to do a lot more work. So you can eliminate paperwork, for example, so all the police reports can be automated and digitalized. He can ask for backup. Instead of doing that over the radio, he can send a distress signal or ask for backup. This will go to the command and control center. That will be streamlined to the other organizations, so either to ambulance or to more police officers or whatever backup is requested. And he himself can see that the backup is already on the way and how much time it will take until it arrives and so forth. So it becomes it becomes a very interesting tool for the officers on the ground that will empower them to make their work much more efficient and effective. And finally, an example of another layer on top of all of that on significantly reducing response time. So with all the information you have, still you can work on a better allocation, better distribution of your resources. So the question is, with all the information we have, how do we distribute when we start our day? Where do we position the different resources? And here is an example, a case of usually how distributions are done, which is just geographical. So make sure that each officer covers a specific area. And if you look here, there is, for example, one area which is unattended. So just ask this guy to go in here. You give them the plan at the beginning of the day. You know which routes in which area you're supposed to cover. Not related whatsoever with any geographical information on where incidents could be taking place or where we have a higher probability of something happening. And then, if you put a target of response times, which is now increasingly becoming the case, that cities put targets and say, okay, we want to reach a national average response time of 8 minutes. So on average, within 8 minutes, if you give us a call, we will be there. Now, you don't have enough resources to distribute the vehicles in a way that really guarantees that they will arrive in 8 minutes. But you can optimize the allocation to make sure the probability is much higher. So here actually what we're showing here, this is an Esri-based, GIS-based solution that actually allocates vehicles, and that will tell you the reach, the 8-minute reach. So any incident that will take place within the red areas, within the red zones, will be reachable within 8 minutes. And this is also related to traffic conditions and all the geospatial information around the traffic and the situation on the ground. Yeah. Now, if you couple that with predictive analytics, so based on all the information we have, we can predict that at this very moment, these are the areas where it's very likely for incidents to take place. So you start drawing your heat maps, and you see, for example, that here is one area where it's very likely for incidents to take place, but it's not reachable within 8 minutes. So you just send the command to the guy, to the application inside the vehicle, reallocate the vehicle, and then you have actually higher probability. There's always a chance that something's going to happen over here, but at least you have completely optimized given the limited capacity that you have. So this is an increased, additional layer of optimization on top of what we have been discussing there. So one last scenario, which basically sums up the whole story and which goes more into crisis management as well. If you look at this here, you have a fire sensor, which tells you immediately that the fire broke out. And then the system will tell you, coming from other sensors, that there is a certain wind speed and that this is near a very crowded zone. So from here, actually you say this is not a normal fire in an isolated place. This could potentially turn into a crisis or into a major incident. So based on that, you start communicating with different agencies. You start monitoring your social networks, you activate the cameras to initiate domain awareness. You make a readiness assessment, so you start looking into hotels, administrative buildings, hospitals nearby. You start putting them on alert so that they're ready if needed. And then you start proactively bringing the right set of vehicles and capacity to respond to the possible crisis nearby. So you have still 1 or 2 vehicles maybe handling the fire, but you have enough vehicles nearby in case it turns into a bigger incident or into a crisis. So using detected infrastructure and connected smart city infrastructure. Here we're not just talking about police cameras, but we're talking about integrating city infrastructure. So cameras and different systems related to traffic, related to other agencies. If you hook them up together into a central platform and give access to public safety organizations, you will be able to handle these kind of incidents in a more effective way. So overall, integration is key, connectivity is key, collaboration and communication between agencies is key. With the right infrastructure in place and with the right sustainable architecture that you set up for your city, you become much more smarter and you enable your public safety organization to become smarter and safer. So I hope this was useful. Any questions? I'm not sure if I took longer than expected or not, but I tried to keep it compact to give room for any questions or discussions.
Guys, floor is open for questions or comments or polls.
Yeah, talk some about the infrastructure, the architecture of the system. And tell us about it. How much of this would an average U.S. city have in place that could be knitted together? How much of it has to be built from scratch?
Well, I wouldn't say that there's a city which really does the full story. So everything we talked about today, these technologies exist. We're not talking about crazy ideas for the future. I think selectively, individual cities have implemented separate components from all of that. The main challenge is, of course, that the infrastructure itself is very expensive. So it's really difficult to, from one day to the other, to get all your radars connected, because there's so many radars out there which just simply are not connected to the network, which just work offline. But at least for future planning, if you have a roadmap where you say this is the vision, this is where we want to reach, then not just within the public safety organization, but as a city, you would start building around this vision. So actually, when you acquire new radars, when you set up your camera systems, when you put in your laws and regulations, you would start putting all of this into consideration. Several cities and countries now put regulations where actually the privately owned cameras, not privately owned, but owned by private organizations like hotels, or, that they need to send the feed back to a specific control room to give selective access in case, so that you have more eyes basically on the ground for these kind of things. New York is very sophisticated, so I think New York are the closest one to this story. They've done this huge implementation over 10 years. But for example, New York, they don't have the one thing that Abu Dhabi showed in its video at the beginning, which is the smart light on top, which would embedded face recognition and all of that. So this is something which I think Abu Dhabi is one of the first cities to really implement it that way. So you would look at different initiatives, and you would think if you combine all this together, then you have maybe a perfect setup for public safety. And then the concerns around Big Brother and privacy, all of that is obviously always going to be an issue. I'm here to talk about the public safety side. I'm not a big expert in privacy laws, but it is very clear that if these technologies are in an ethical and proper way are implemented, then it can keep our cities much safer. I mean, we all crave for more safety, and especially these days. So, from the architectural side, I think that's a good question. I think I do have a slide. No, actually, I left the technical slide out because I thought it's going to be more on the feature side. But basically, there are different. You would always need a national integration model. So you would need to have. And there are all the big technology companies that provide that. So you would have IBM, they have this, it's a product called IOC. Microsoft has built its own, which is called Connect, and you have Oracle, SAP. So is there a next slide in the beginning?
Yeah, at the beginning, you had the slide, maybe the second or first slide we were showing Connect.
So I have another.
Down here. Yeah.
No, I have a better one. Okay. Okay, that's a very technical slide. But this is the integration. Basically, that would be the single point of truth. And all what it does is it would get the data and it would correlate it and store it. And then you can build other applications on top. So you can put in different components. You have the Aware, which is the New York implementation. You can do a JS Azure-based implementation, which is, for example, the application I showed you about the smart allocation of police. You can build your fleet management and your 911 emergency management solutions on top. You can bring here applications that, for example, a social network monitor, which does sentiment analysis based on the feeds coming from the social networks. So that would be the conceptually high-level architecture. We have third-party systems, radars, speed cameras, all of that. Obviously, they have to be connected. You would plug them into the integration hub, and then you can put your applications on top.
What is the term sentiment analysis?
Sentiment analysis monitors tweets and Facebook feeds, and it would analyze basically the sentiment of what people are tweeting. So on the highest level, it will tell you if people are happy or not. Okay. So you can do sentiment analysis in a city, and then go to the mayor and tell him, look, your citizens are not happy, you have to do a better job. That would be the highest level of sentiment analysis. But it can go a bit more detailed, and it can go down to a level where you actually identify people who are friends. So if somebody frequently tweets, I don't know, fanatic religious things, quoting people that have fanatic backgrounds, for example, and then correlate that with some tweets about how they're not happy with their jobs or whatever, or with their personal life, then you say, okay, this guy is a possible threat. I mean, that's, I think, the most sophisticated level it would go down to.
To track things like flash mobs or things like that, where people are tweeting each other, okay, let's all go to this particular place.
Exactly, yeah. So you have trends, yeah, so general sentiments and trends. I know it's heavily used in some countries for demonstrations, so you can predict that demonstrations are going to take place if people start, mobilizing each other, and sometimes they use it to. I know for a fact that in Egypt there has the government did an implementation, a sentiment analysis implementation, where they're actually tracing back to see who initiated the demonstration, because in Egypt that's illegal. So they use it actually to catch the guy. So there are different ways you can apply sentiment analysis, and there are several companies out there that are very specialized in this area.
So when it comes to the fire analysis in Abu Dhabi, is that more on the commercial end, and has there been problems or complaints from like the responders and that they're like false alarms or something, or how is that? Can you tell me more about how the fire alert works?
Yeah, false alarms, these kind of things, usually there's an action plan, so it's not necessarily whenever somebody calls or whenever the sensor triggers that I immediately send my whole force. Usually there is a standard operating procedure that you follow. Very often, the standard operating procedure includes verification. So it includes a callback, for example. It includes checking out the video camera, see if there's. So usually there are some steps you have to take.
Is it like in public buildings, or what type of companies or people would allow that?
In Abu Dhabi, it's not that sophisticated yet. In Dubai, it's I think in almost all the buildings.
Okay.
So there was a major implementation over the past years where they actually install connected fire sensor in all of the buildings. So it's not just public buildings.
So the country did that for the buildings. It wasn't the buildings electing to do it, essentially.
I'm not sure, but I believe it has become law, meaning that if you make a building, you have to install these kind of sensors, and you have to be connected. Yeah, so it's become a regulation. Because if you leave everything to the government, there might not be the right budgets and efficient resources available to do these kind of large-scale projects. So
And potentially that's how people are getting their cameras on the system too.
yeah,
The legal.
I mean, most of these cameras they're private cameras, so they belong to hotels or restaurants, so they're not necessarily owned by the government.
Well, I can imagine that in a highly centralized society, this becomes an easier thing to implement. In a highly decentralized society, such as the U.S., it takes quite a lot of effort just to get the cooperation to feed the video, just for the videos part of it. So, to what extent do you think this is a reasonable or an appropriate solution for, especially Western societies?
I wouldn't position it as a blue chip product, if you like, that you take it or leave it. So I think it could be a North Star objective, where you say, for us to be safe, this is where we should reach, and based on that you try to get as close to the goal as possible, maybe only implement parts of the solution. You're absolutely right, you'd be surprised how sophisticated, for example, countries in the Middle East are when it comes to public safety compared to Europe. If you read all these critics around the way, for example, France responded to the terror activities last year, and how much they were saying about the inefficiencies of the organization because they're not working together and so on. And then you look at, for example, the fire brigade, it's a very traditional, old-fashioned, very proud organization. So there's a lot of ego and politics. And police is a completely different island, and they're not necessarily cooperating very well with each other. And when this happened, when the incident happened, you had to have a very good coordination between the agencies to better respond, and this was not there. And I was at the ENA conference in Prague last year. ENA is the European Emergency Number Association. So basically, they're like in the US, the 911, it's called the NINA, the standard body. They're the ENA, which is 112. And they were talking about this big time, and they said that it's actually the biggest challenge they have is bringing these agencies to talk to each other and work together. If you go to Abu Dhabi, it's one control room, and everyone is in there. So it's like you have a call taker, he receives whatever calls, and you'd have an ambulance guy, a civil defense guy, and then inside the police organizations for each one there's one guy. So it's very centralized and it's much more effective and coordinated. But that's because it's a very centralized government.
I'm assuming the algorithms are, for the most part, I mean, this is really promoting machine learning or taking advantage of machine learning.
Yes.
And so what happens when something in the external environment changes? For instance, new privacy standards about using facial recognition software that comes from legal decisions. So how does the system accommodate that, where you've got those sorts of developments?
That's a big topic at the moment on how to get the systems to follow the regulations. I think it's just a matter of making the systems configurable enough to adjust to different levels of security. I could give you one example. Cloud versus no cloud is always a topic. Yeah. So public safety now, because there's so much data, especially coming from cameras, and if you start also talking about police wearables and stuff like that, it's almost economically impossible to put that on-prem. You need a cost-effective cloud solution that can scale up, has cheap storage and all of that. So many organizations start looking into a hybrid setup where you have your on-prem real-time data, for example, officer locations, incident details, these kind of things. But then the analytics and machine learning parts would be offloaded to the cloud. You process, not store, just turn back the results. And then all the heavy raw data from the past, like video archives, you just keep them on the cloud. So the setups in the future need to be done in a way where you can adapt to these kind of classifications. And increasingly, if you look at the way Microsoft is setting up the Microsoft Cloud, the Azure, for example, they start looking into that. So how to set up an architecture makes it very easy to really distribute the data in a way that can adapt to different regulations and maybe even change over time. Yeah. But it's not easy. It's quite challenging.
And what do you do about what is always a major problem? Because part of what you're doing is not simply collecting sensor-based information, you're using existing data, because you'll always have to continually mine it just to see what the various histories of particular people there may be. What do you do when those data themselves are incredibly messy? I mean, that's a huge problem in itself. How does the system clean data?
It doesn't, no. That's one of the big challenges. What the system does is it would improve itself over time. So as more data come in, it would get closer to the truth and discard messy data. But that takes a long time to process. And that's what actually machine learning is all about, right? So as the more data comes in, the more intelligent system becomes, the more accurate it becomes. Data cleansing is a very big science of its own, and of course you can build up data cleansing tools and so on. But I can bring up some stories from our fleet management implementation. So 10 years ago, we started building up a fleet management solution, and we would use it's a hardware independent software. So we use trackers coming from different companies, install them into vehicles, and then all this data comes back to our system. Now these trackers, we can unify the data, of course, when it comes in, but they all behave in different ways, and they send the data in different ways, and some are more accurate than others, and some behave strangely when they can't read the satellite properly. Some do data cleansing inside, so they're more intelligent, and some they just send whatever rubbish they get. So we started building up a data cleansing mechanism that would clean the data as it comes in, and it would run through the whole stack regularly to find and trace data that is inconsistent, that doesn't seem right, and it would take it out. Like jumps, for example. So the vehicle goes to a specific route, and then you have one location here, and then it goes back to its route. So this is obviously a messy data. So the system will detect that, and then can you reach the single point of truth where all data is accurate? No.
Is Microsoft connect the application hub is a product or is a custom-made application by Microsoft?
Okay, it's a good question. It's the first time someone asked me this question. It means that you're really acquainted with how Microsoft works. So Microsoft, they have the product, they have their products, which is like Windows and Office and all of that, yeah. And then they have the services team, which is more a bit like IBM. So they build IP, and they use the IP to drive implementations. So this is an IP that is being used as to drive an implementation. But it's not a product where you just buy the license and you take it to install. It's not like this one. But I'm really happy that somebody's asking this, because I always nobody understands what's the difference between a product and an IP. So. It's very technical.
People say, can I download Connect? Very good, thank you.
Just a quick commentary here to put this in the big scheme of what we're doing in smart cities. So basically, thank you so much for thank you. That was great to to start. We're trying to do the smart city, it's a smart edge presentation to start to understand what's going on in this big. It's very complicated, as everybody can see. And we have seen last time some stuff about the data, and we have mixed wisdom from Asia is going to talk more about the data analysis, things like that. But that was the first time actually we get to exercise with the sensors, when you have sensors integrate to each other. The example was the fire alarm that basically can communicate directly to the fire response, or for example the road alerts when there's some sort of fog or visibility problem. Just this example of what we call Internet of Things, and how the Internet of Things actually becomes part of sensor communication, and then how this comes to the data. So it's just, I wanted to start basically like, as we are looking at this, there are so many aspects. There are stuff about big data analysis, stuff about integration between so many, sensors and things, what we call Internet of Things, stuff about processing of the data integration. And then some of the questions that David has posed about basically like, privacy. So there is other aspect of how these data are handled, things like that, the governance of these kind of systems, and hopefully in the future, talks will bring some people to, cover this part. Nour has presented the first one, the concept of the CityNext platform, the CityNext basically framework of smart cities, talk about safer cities, healthier cities, sustainability. So it's not only about public safety, but the same concepts extend to healthier, solutions, or something has to do with health systems, has to do with sustainable farmer agriculture. And one of the projects that we are working actually in New York on Monday, I'm traveling with Nour to discuss our venture project that will call center being partner with Softec for sustainable agriculture. So it's around the same concept. So just start actually just open our mind to see the different aspects of that.